Hi, I'm John Paulraj, and I'm on a mission to make the learning of math fun. This is part 2 of Algebra of Inverse Functions. So if you haven't already seen part 1, please check the link in the description below. On this video, we are discussing the inverses of a square function and a square root function. Let's start. We are going to use the same two-step procedure as we saw in part 1 to find the inverse of a function. First step is to interchange x and y, and the second step is to make the new y the subject of the formula. So when we take a look at the first example, f of x is x minus 1 the whole square. The first thing to do is obviously to identify y as f of x. So we write y is equal to x minus 1 the whole square. Then we interchange x and y. And so that would make this equation x is equal to y minus 1 the whole square. Okay. Now I will take the square root on both sides to get plus or minus square root of x. Be careful when you do this. Okay. So plus or minus square root of x is equal to y minus 1. Okay. That's square rooting both sides. And then when we write in terms of y, we can say y should be equal to 1 plus or minus the square root of x. This new y that we have is the inverse. Okay, so f inverse of x is 1 plus minus under root of x. Let's take this one step ahead and write down the domain and range of the function f of x. Okay, so to do that, let's go to the graph, and we know that domain means looking at all the x values from left to right. Okay, if you have not seen my video on domain and range graphically, I'll put the link in the description below. Please go and take a look at it. The domain of this function, as we can see in the graph, is all real numbers. But the range of this function, as we look along the y-axis from bottom to top, is from the minimum value, that is 0, all the way up till positive infinity. So when we write the domain of this function, we will write that is negative infinity to infinity. And the range of this function would be 0 inclusive, that's the minimum value of the graph, to all the way up to positive infinity. Okay, that's the domain and the range. So now if you want to write the domain and range for the inverse of f, we can just interchange this and say, okay, that means the domain of the inverse would be the range of the function, right? So it should be 0 to infinity. That's the domain of the inverse, and the range of the inverse should be the domain of the function, which should be negative infinity to infinity, right? That's what we saw earlier. Let's verify this on our graph. Okay, so there we go. The inverse is in red color, as you can see, and that magenta line is y equals x. Okay, and you can see clearly that the domain of the inverse of this function is 0 to infinity, all values of x, okay, going from left to right along the x-axis, 0 to infinity, and the range is from negative infinity to infinity as we go along the y-axis. But there's something very interesting going on here. Take a look at this graph of the inverse, the red graph. Every vertical line will cut this graph in more than one point. What does that mean? That means that the inverse is no longer a function. For those of you who haven't seen my video on vertical line test for functions, I'll link that in the description below. Please go and take a look at it. The inverse, the red graph, every vertical line is going to cut it in more than one point, in 2 points. That means the inverse is not a function. So this is a great example of a function, f of x is equal to x minus 1 the whole square. That is a function. The green graph, that's a function. You see every vertical line will cut that graph in only 1 point. But its inverse exists as a relation and not a function. Okay, that's a very important point to make a note of. So we can make a note of that here, that this inverse is a relation. It's a relation, not a function. Okay, second example. This is a square root function, square root of x plus 3. Let's write down this as y is equal to the square root of x plus 3. That's the first thing to do. And then we'll interchange x and y terms to get the equation as x is equal to the square root of y plus 3. Okay, now we square both sides. So I'm going to write that thing down and say squaring both sides, we will get x squared is equal to y plus 3. And then when we write in terms of y, we can write y is equal to x squared minus 3. And that new y that we have found out is the inverse of f. And f inverse can be written as x squared minus 3. All right. And just like we did in the first example, let's write down the domain of f of x, okay? The domain of f. The domain of f, as you know, that we need to find the domain by putting this term inside the radical greater than or equal to 0, such that you'll get x plus 3 greater than or equal to 0, which means, can you see this in the camera? Okay, x must be greater than or equal to negative 3. So the domain of f would be written as negative 3 included and infinity. And the range of f would be 0 to infinity, because the minimum value of the input is negative 3, which means the minimum value, minimum y value would be 0. So 0 to infinity would be the range of f. Now let's write down the domain and range of the inverse by interchanging the domain and range of the original function. You know, that's what we saw earlier on. So the domain of the inverse should be this term out here. This is the range of the function, right? So the domain of the inverse ought to be 0, infinity, and the range of the inverse must be negative 3, infinity. Is it right? What we've done is the domain of the function is the same as the range of the inverse, interchanging, and the range of the function is the same as the domain of the inverse. Can you see that? But let's try and verify this graphically, okay? Keep an eye on this. So on the graph here, we have got the green graph is a graph of the function fx is equal to square root of x plus 3. And you can see that as we go along the x-axis from left to right, the graph starts at the input value start at negative 3. And so that's fine, negative 3 to infinity. And as we go along the y-axis from bottom to top, for the green graph that is, the output values are from 0 to infinity. So that's fine, negative 3 to infinity, the domain, and 0 to infinity, the range for the green graph is fine. But the domain for the inverse function x squared minus 3, the red graph, is actually from negative infinity to infinity. Look, when you go along the x-axis from left to right, that includes negative infinity to infinity. The range, however, is from negative 3 to infinity. That's okay. But the domain is negative infinity to infinity, whereas when we made a note of that domain of the inverse here, we just said, okay, 0 to infinity and not negative infinity to infinity as it's evident on the graph. Can you see the red graph again? Okay, along the x-axis, negative infinity to infinity. If you had just found the inverse algebraically and you put it on the graphing calculator to check out the domain, you'll say that, okay, the domain of this function is negative infinity to infinity. But why are we getting it here this way, that it's 0 to infinity? And here we have to be confident of our algebra and say that, you know what, regardless of what's going on in the graph, we need to be consistent with the idea of the interchanging the domain and the range and say, hey, the domain of the function must be the range of the inverse, and the range of the function must be the domain of the inverse. So this is correct because only when we have that kind of an interchange, the domain becoming the range becoming the domain, only when we have that kind of an interchange is the inverse even possible. So when we go back to the graph and take a look at the function again, when you look at the green graph again, that looks like just one piece or one side of the inverted parabola. Whereas the red graph, the inverse has both the pieces. So what I'm going to do is that I'm just going to change that slightly, okay? And I'm going to just turn on this magenta graph, and the red graph, I'm just going to turn it off. And now when we look at the graphs, we can see that the magenta graph is the inverse, except that we've restricted the domain x greater than or equal to 0, except we've restricted the domain. And now we can see that, yes, there are mirror images about that line y equals x. That blue line is the line y equals x. And you've got one piece, just one piece of the inverted parabola and just one piece of this parabola. Okay, so that makes sense that when you restricted the domain, you get the reflections as per the definition of the inverses. That means that when you write the inverse, you must specify with a comma saying that x must be greater than or equal to 0. What you're saying is that the domain is now restricted to greater than or equal to 0. This is the same thing. X greater than or equal to 0 is the same thing as we saw here. The domain of the inverse must be 0 to infinity. Okay? We saw that the inverse of a function is not necessarily a function. And we also saw that as a consequence, why it is important to specify that restricted domain when we write the expression for the inverse of a function. In the next part, we are going to discuss the inverses of rational functions. I'll see you there.